So we've got one more review here of some of our basics before we get into thinking about the unit test. So up at the top here, these first 4 questions are just simplifying. I don't need a common denominator or anything. So I take a peek at my help sheet and I say, okay, factor everything. Well, do I see anything to factor? Well, no, there's no pluses or minuses. Okay. Cancel exact terms. Well, I don't have things that are exactly alike. I see some m's and things, but oh, reduce monomials. These are all monomials. So I can do a few things. 30 over 15 reduces. 30 divided by 15 is 2. So when I'm doing this, I'm like, okay, well, why'd you put the 2 up top? Because that's where the bigger of my 2 coefficients is at. Whichever the bigger number is, I put it there. And then what's my rule for exponents when I'm dividing? Subtract them. So 2 minus 1 is 1. The bigger one's up top. And I'm done. If you want to put a 1 and keep it as a fraction, you can. But you don't have to. And that's all I'm doing on the regular simplifying ones. If you're not sure on numbers, remember the calculator's always there to help you too. So if you get to number 2 and you're like 63 and 42, 63 divided by 42. No decimals though. Let's see if math enter enter helps. Ooh, that was nice. So 3 halves means it's 3 over 2. And then I use my exponent rules again with my a's. I'm like, okay, 2 minus 1 is 1. Oh, but the bigger exponent's down in the denominator this time. So that's where my answer is going to go. So sometimes it's as simple as just doing some simplifying. But again, I've got to be careful. I'm going to do this. Again, every time you see plus or minus, before you go and give a Band-Aid offense, go and cancel something you shouldn't. Put parentheses and then factor everything, even if it's just something they have in common. So like what do these 2 guys have in common up in the numerator? 10, anything else? 10m. So if I take that out, I go, okay, 10 times 3 gets me to 30. And I've already got 1m, but I need a second, so 3m. And then I got to be careful. I know some of you are going to look at this and say, well, it's already 10m. 10m and 10m, I don't do anything. I just leave it. First, there's a minus there. And second, if they're exactly the same, I still have to use a 1. Because if I distribute this back through, it gets me back to the original problem. So at this point, once I've factored, the whole reason is now I have parts of this that aren't bonded by plus or minus anymore. That's the stuff I can reduce or cancel. So again, if you need to do a little calculating here, if it doesn't jump out right at you, 10 divided by 80, oh, 1 over 8, okay. 1 over 8. My m to the firsts cancel, because they're the same. And the 3m minus 1 is up in the numerator. I'm done. So those are the type things that we're trying to look at when we're doing these. Now I'm going to cover up the projector here for a minute. I want you to look at number 4, see if there's something in common, and see if you can get that reduced down for a second. And then we will come back together and see if both of us have the same thing for our answer. Factor, cancel terms that are alike, and then see what you have left. And so if I did everything right, if I took out a 10 and an m, I'd have an m plus 5 left, and when parentheses are identical, I can cancel those. So that works out well. The thing that you got to watch for here is, since the 10m's in the denominator, I got to put a 1 up here. If I just write 10m, we assume that it's up here, and that would be wrong in this case. So, again, just kind of factor and cancel. So then the next part kind of goes the same way. We just build on it a little. We're going to simplify each expression. Remember, if you divide, you need to flip. If you're adding or subtracting, you need a common denominator. Use the help sheet. We're doing all multiplying and dividing up here. So again, we want to factor everything if we can. If it's division, we flip. Let's even do this. We flip the second fraction, that is, and it matters. Cancel things that are alike, and then again, we reduce monomial terms if we can. And the number of these things you have to do will be different for every problem. Sometimes I'll have to do all 4. Sometimes I'll only be doing number 4. It just depends. So like here, for instance, it's multiply. I don't need to flip. So what I normally do with monomial terms is I multiply across, straight across, not like cross multiplying, but straight across. And then I look to see if I can reduce anything anymore. So I look and I'm like, oh, let's see, 50 divided by 9, math, enter, enter. Oh, it didn't reduce anymore. Okay, that one I happen to be done already. Sometimes nothing's going to happen. It just works out that way. Now other times, it may work out a little better. Multiply across, because we want to get to one fraction so we can use our rules. So I multiply straight across, and I look at that for a minute, and I go, okay, 56 divided by 8 is 7. 56 is up in the numerator. That's where my bigger number is, so that's where my answer goes. And then I use my exponent rules for my x's. 3 minus 2 is 1. Bigger exponents down here. I'm good to go. So if they're monomial terms, I would say get it to one fraction and then start trying to reduce things and cancel. Well, what if there's other stuff going on? What if I have things like all of these sets of parentheses? Oh, that's like heavenly if we get all these sets of parentheses. I guess for some reason we forgot them on the others. In this case, you can cross-cancel. You can cancel numerator to denominator. Ooh, this is kind of slick. Everything went away. It's just 1. The only thing I can't do as far as canceling goes, I can't cancel side to side. So like if this would have been k minus 7 and k minus 7 next to each other, they don't cancel. But it's going to be detail oriented. It's going to be our big thing on this. Okay, here, I have to flip the second fraction, not the first one. And then multiply my way across. So once I flip and multiply across, I notice a couple of things. One thing I notice is the x squareds are the same, so they cancel. That's slick. And then I would just math enter the 32 over 40 if I wasn't sure, and get my answer that way. So again, not a bad thing. So I keep looking and I'm like, okay. Ooh, multiplying. So again, to keep yourself from being that person, the Band-Aid person, we cannot cancel these R's. Okay, I can't cancel here. Remember, anytime I see plus or minus, I gotta put parentheses around to remind myself of that so I don't do something silly. But I do want to look to see, can I factor anything? And I can. I can do a diamond on this, and it'll absolutely work. So I might sit here and say, okay, let's see. Everything's pluses, all right. So let's see here. I need to multiply to 18 and add to 9. What would that be? Okay, so 6 and 3 add up to 9 and multiply to 18. So once I factor it, let me get rid of the old one here. But now that it's factored, I might be able to go cancel crazy. Ooh, those are the same. They're identical. I can whack those. Ooh, these are identical. This is where I wish I had my little noise-making hammer with me. So everything canceled except this 9 that's up in the numerator. That's my answer. You're like, could I put it over 1? You could. That wouldn't be an incorrect thing to do. If that makes you feel more comfortable, you can do that. But whenever we're multiplying and dividing, you've got to say, what can I factor first? That always has to be the first question. And so I'll normally just go from piece to piece going, okay, let's see. Ooh, these both have an M. Ooh, I can take a 6 out of both of them. Okay, even if you take out a smaller number, it at least would be a start. I can't do anything with 4m squared, so I'll leave that alone for a minute. Ooh, but I see a plus, make that parenthesis. And then I just do the same thing with my other part. And I'll take this back off in a second if some of you are still jotting things down. I can take a 4 out of both of those. Ooh. Now here, when I'm factoring, different from an LCM, when I'm factoring, you take out the smaller one. So the smallest exponent I see is m squared. 4 times 6 is 24. So it doesn't always have to be a diamond or something fancy. Sometimes it's just going to be taking that out. So I start looking around now and I'm like, okay, now I'm going to peer for things that I can cancel. Parentheses are identical, cancel. 4m squareds are identical, cancel. Then I have to be cautious. I have a 6m left up here. I have an m plus 3 down here. Can I cancel these m's? No. Parentheses. The only way I can reduce this more is if I have another m plus 3 somewhere. That's as far as I can go. That's what some of you've got to watch for on those. Because you tend to get a little over-cancel-y, if that's a correct term, which it probably isn't, but you get my drift. So we kind of keep playing with these. I want to do one more of them here. I want to do 11. Because I got a couple things going on here. First, that second one's going to flip, but for right now, I can diamond this guy. So I'm going to do that first. Let's see here. Multiply to a negative. We have one of each. Let's see. Multiplies to 40, adds up to 6, 10, and 4. Reminder again, because we've talked about this before. If doing the factoring part, if it's the multiplying and coming up with factors term that gets you, remember, we've got the factoring help sheet, and if you weren't sure what to do, you could just go on the flow sheet here and start looking for 40 and start looking for pairs of numbers until you find one that works for you. There's nothing wrong with that. And then here, remember, these flip. I can take a 9 out of both. Sometimes that's all I can do. 9 times what gets me to 9v? V. 9 times what gets me to negative 90? Negative 10. And once I'm fully factored, now I can go back and start looking for things that are identical to whack. And go about my business. Okay? So multiplying and dividing. Don't need a common denominator. Just factor, 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 cancel, cancel, cancel. When we get to adding and subtracting, it changes a little. And this is the part that we've struggled a little bit. You guys have been great on 9-6. For those of you who have been watching doing things, you're spot on. So here's my one worry point. Okay, adding and subtracting. We need a common denominator. Now, of course, if we need to, we're going to factor the denominators if we need. If we can't, we don't worry about it. But then once we do that, we need a common denominator. Well, sometimes we're going to get lucky and we're going to have one already. So if that's the case, all I have to do at this point is combine like terms. 1x plus 1x is 2x. Negative y, or negative 1y, plus 2y is a positive y. Again, there's a plus in there. Don't cancel the y's, or the x's for that matter. That's as far as I can go. I gotta watch signs. If it's minus in the middle, don't plus. They're common denominators. That makes me happy. 4 minus 5 is negative 1. Okay. If I get a common denominator, I like this. It makes it easy. And that's a good thing. But they're not always going to be common like that. Sometimes I'm going to have to look and say, okay, I'm trying to build my denominator. So let's see. If I started counting by 3s and 4s, first number that'd show up in both lists, 12. Now, if you want to, you can just multiply the numbers together. Sometimes that may get a little big, but that's okay. And now for my exponents, I'm always going to take the bigger one, but you're like, well, the x's are both the same. Okay. Well, the y squareds are both the same. Okay. This is the part that seems to have gotten us, because some of you have gotten really better with figuring out the common denominator, but now it's figuring out, well, what do I have to put in? Remember, you're going from the old denominator to the new one. Whatever I need to multiply to get from here to here is what I need up top. So 4 times what is 12? That'd be 3. I already have the x. I already have the y squared. Okay, so the only thing I needed was the 3. So here, this times this gets me this. And I do it one more time. 3 times what gets me to 12? 4. I've got the x. I've got the y squared. So my building part is done. So the only thing left, once we do that, keep my denominator, my newly found common one. 3 times 3 is 9. 2y times 4 is 8y. There's a plus in the middle. Don't forget the parentheses. Now, I wouldn't mark it wrong if you don't put parentheses. I will mark down, though, if you forget when the parentheses and you try to cancel the y's out. And I'm going to be like, so depressing. So that's where I'd get my build from on that. So anytime I'm looking at these, again, it keeps coming back to your denominator. Now we got a little fortunate on this one. We just had 3 and 4 on the last one, so we have it again here. So 3 and 4 would be 12. And I do have an x, so the x has to be included. Single variables, we've talked about that. Whatever's there gets to stay. And then again, old to new. This times whatever I times it by is going to be this. So I'm like, okay, 4 times what gets me to 12? 3. Ooh, but I need the x. I don't have the x here. Okay. And I've spoken with some of you about if this doesn't work for you because it seems a little abstract, if you do a little side work, you're like, okay, 4 times something equals 12x. And then you look at it this way instead, you go, well, 4 times 3. Oh, I don't have the x yet. 4 times, yeah, that works. And then that's what you put in here. That's cool. It just depends on how visual you are with this. And then I just do the same thing over here. 3 times what gets me to 12? 4. But I already have the x this time, so I don't need it again. So 5 times 3 would be 15xy plus 24x. Let me put my parentheses here. Ooh, now here's where I gotta be careful though. We haven't had one of these yet. So I get to the end and you're like, what? We put parentheses around, those aren't identical. You know, what are you talking about? Adding and subtracting. Factor the numerator if you can and cancel. Do those two terms have anything in common? 3, anything else? Okay, they both have an x. So I factor that out. I go, okay, 3 times 5 gets me to 15. I've already got the x, so I need a y. And then 3 times 8 is 24. I've already got the x. Ooh. So you're like, okay. But wait. I can't cancel the parentheses, but I look out here. Like, dang. The x's cancel. 3 over 12 is 1 over 4. Now I'm done. Now, let's chat for a second, though. Let's say this were a question on the unit test, okay? This is probably going to be 1 for the LCD, 1 for building, 1 for getting it together, 1 for reducing. So let's say it's a 4-point question. If you get to here and stop, you're going to get 3 out of 4. Because my main thing is, do you know how to get a common denominator? Do you build it? Did you put them together? Good. This is just the bonus point in, can you take it that last step? And hopefully, with the help sheet there with you, it'll remind you to do that. But that's what we're doing. I want to do 17 and 18, and then I'm going to be done here. Because I want to give you some time to work with these two. So, okay. Parentheses abound for our pluses and minuses. I don't have any coefficients that are loose down here. Okay, everything's in parentheses. I don't have any variables that aren't in parentheses. So my LCD just ends up being both of these. Now again, I'm not going to be, well, I better do this first before I say that. Old to new. I've already got the 2p minus 5. I need the p plus 5. On the second one, it's just the opposite. I've already got the p plus 5. I need to put the other one in. And here's where some of you do beautiful work to here, and then it all goes downhill. So here's how we're going to fix it. I can't cancel yet. Okay? The rules say simplify the numerator, collect like terms. It says nothing about canceling. Then factor and cancel if needed. So there's no canceling until the very end when we're adding and subtracting. So don't cancel the p plus 5s. Don't cancel these, because it'll just get you back to the original problem. So my job here has to be doing some distributing and combining of like terms. So I'm like, okay, well, I'm going to do it this way because I want to see everything that's going on. So I'm going to do my distributing. So I'm going to look and say, okay, like terms. 3p, 12p is 15p. 15 minus 30 is negative 15. Parentheses. Before you circle it, give it one last peek. Look at your numerator. Is there anything in common in your numerator? 15. We're going to go into sideways here, people. They're like, whoa. So I factor out my 15. Now some of you may look at this in a minute and say, well, wait a minute. You factored it, but nothing cancels still, because that's not the same, and there's no other coefficients. So if I didn't do this step this time, if I left it back at this, would that be right? Yes, in this case it would be. But do you want to gamble that every time that you don't factor it, that it's not going to go further? Because we just got done with one that did go further. So I really have to be careful when I'm doing this to make sure that I'm getting completely to the end of my problem. Last one. I look at this, look at my denominators first. If anything's factorable, that needs to get done. Ooh, there is. I can take a 3 out of those two guys. So if you can factor, you need to. Otherwise, this gets really messy. So I start looking and I go, okay, I need a least common denominator here. Step 1, coefficients. Counting by 2s and 3s, what number am I going to run into first? 6. So we got a 6. I have a single variable. That guy's not locked up with a plus or minus. So that becomes part. And then I have a set of parentheses. I need them all. Okay, this m and this m are not the same. This one's locked in with the plus 6. This one isn't. That's why I have to have both of them. And then again, one last time, build it. I got the m plus 6. 3 times 2 gets me to 6, and I didn't check off the m. So 3 times 2m is 6m, and I already have the m plus 6. I do it one last time here. I've already got the m. 2 times what gets me to 6? 3. And I didn't check off the m plus 6, so I need it. This one's going to take a second. So we got to clean up some stuff, but that's okay. So I start to look, I'm like, whew, this is going to be a little bit of a doozy. I'm glad we're not doing 20. We might need the room. 6m, m plus 6, so 2 times 2m is 4m. Minus. Okay, my suggestion. The stuff that's on the outside of your parentheses, I'd multiply it together first. So I'm going to cross this out. I'm going to call it 18m. And I'm going to distribute. Now here's where I have to be cautious. I'm minusing this whole thing. So I'm going to put some parentheses up here. So 18m times m is 18m squared. 18 times 6 is 108m. Oh yeah, we're definitely going to take over some space here in 20. So why'd you put the parentheses, Harty? Because the minus doesn't just go to the 18, it goes to this too. It's going to go to both. So you're like, ee. So let's see. Negative 18m squared. Then 4m minus 108m. Ew, yuck. You're like, this is going to be one of those ugly ones, isn't it? That like goes on forever. Again, if this is a 4-point question, you get to this point, you have 3 of the 4. The question is, are you going to get that last partial point out of me? Well, let's find out. So, let's see. Do these two guys have anything in common? Let's see. I see they both have an M. Okay, I know that part. I know that for sure. 18 and 104. Let's see. 18. We can always start small. I think that would be a good idea. Yeah. Let's try 2. So it's like, all right, so we got a 2m. Let's see, what's that leave us with? Negative 9m. 2 times negative 9 is negative 18. M times m is m squared. And minus 52. Yes, yes, yes. So I look, and I factored, and I'm getting ready to circle it, or square it, or whatever you put a box around it. One last look. Oh yeah, those m's, they can go away. 2 over 6 is 1 over 3. If I want to put the 1 there, I can. Now I look, those aren't the same. Those don't reduce anymore. Happy, happy, happy me. So again, I would use this to maybe try that extra credit one, or maybe use it on the review as I'm doing it to try and help me get through some of those questions, even though we'll be going through the review tomorrow in class. It's something, the more practice you get, the more comfortable you're going to feel come the unit test later this week.